Close your eyes for a moment and picture this. It's a quiet night on Earth, October 12th, 2025. The kind where the stars seem to lean in, whispering secrets meant just for you. You're wrapped in a blanket, gazing into the infinite black canvas of the cosmos, when suddenly, bam! The universe drops a bombshell right into our solar backyard. Breaking news, my friends. Quantum AI scans, powered by humanity's sharpest telescopes, have confirmed something straight out of a sci-fi blockbuster. Interstellar Object 3, I/ATLAS, isn't just passing through. It's not like any natural comet we've ever seen. This bizarre, reddish glowing traveler, hurtling from another star system, is blazing through our cosmic neighborhood at a jaw-dropping 61 kilometers per second. That's faster than a bullet train on steroids, crossing from New York to Los Angeles in under a minute. But here's the gut punch that twists the knife. Earth's mightiest telescopes? They're blinded, helpless against the sun's relentless glare. As NASA's websites flicker offline amid the U.S. government funding lapse that kicked off on October 1st, now dragging into its second week, leaving scientists scrambling, this mysterious wanderer streaks past Mars, defying every law of comet physics we thought we knew. Picture it, a pulsating reddish phantom, its anti-tail pointing defiantly toward the sun like a rebel's flag waving in the void. What ancient secrets does it carry from a distant world? Is it a frozen relic from a long-lost planetary nursery, or something stranger? Your heart races, because this isn't just astronomy. It's a story of humanity's place in the cosmos, a reminder that we're not alone in wondering about the stars. If this hook has your pulse pounding, smash that like button and share this tale with someone who dreams under the night sky. Let's spread this cosmic fire across the globe. The discovery moment was electric. On July 1st, 2025, astronomers at the Atlas Survey in Chile's Rio Hurtado caught a faint blip, magnitude 18, barely a whisper in the starry noise. But orbital calculations screamed interstellar, an eccentricity over 6, the highest ever recorded, charting a near-straight shot through our system. Pre-discovery images from TESS and ZTF pushed the timeline back to May, revealing a wanderer that's been sneaking up on us for months. Emotionally, it's like finding a message in a bottle from across the galaxy. Who sent it? What storms has it weathered? From a Kenyan teacher inspiring STEM classes with this find to a Japanese poet crafting haikus about cosmic drifters, this object unites us in awe. Its reddish hue, born from irradiated organics like tholins, shifts under solar rays, a neon sign from the universe saying, "Pay attention." Unlike the blue-white comas of local comets, this one's dusted with clues of a metal-poor birth in a distant ancient star system. Its speed? 61 kilometers per second at discovery, accelerating to 68.3 kilometers per second at perihelion, record-breaking for interlopers. Feel that cosmic wonder. Drop a comment below. What's your wildest theory on 3I/A/TLAS? Let's build a community of stargazers hooked on this mystery. And check this out. A Hubble capture from July 21st, 2025, showing 3I/ATLAS glowing like a cosmic ember against the starry void. That reddish glow? It's not just pretty, it's a window to worlds beyond our own. Stick with me. The blackout's about to lift in ways you won't believe. From that stellar snapshot, let's zoom into the cruel irony twisting this tale. It's October 12th, 2025, and for 6 weeks, Earth has been trapped in a cosmic blackout. A solar conjunction has shrunk 3E/ATLAS's angular separation from the sun to under 10 degrees, forcing telescopes to shut down to avoid frying their delicate sensors. Imagine the heartbreak. Observatories from Mauna Kea's crown jewels to Chile's Atacama giants stand idle, their billion-dollar eyes averted like guests barred from the galaxy's grandest ball. The elongation angle, the apparent sky distance from the sun, compresses dramatically from late September through early November, creating a forbidden zone wider than 15 degrees, where safety protocols scream no. This isn't just technical jargon, it's a gut check for every stargazer. Picture the astronomers, late nights in control rooms, coffee-stained notes piling up, hearts heavy with what-ifs. A Chilean observer described it to reporters as watching a loved one sail away in the mist, her voice cracking over the line. The U.S. government funding lapse only deepens the sting, grinding NASA's data pipelines to a halt. No updates, delayed releases, teams working in shadows. Yet, resilience shines through. Amateur skywatchers from Sydney to Stockholm pool pixels. Citizen scientists stitching together faint glimpses before the blackout hit on September 25th. Their passion is pure fire, reminding us that science isn't just for lab coats. It's you, me, all of us chasing light in the dark. But here's the plot twist that flips the script. While Earth weeps in the sun's glare, Mars steps up as the ultimate cosmic watchtower. The red planet's orbital dance, its elliptical path granting over 40 degrees of clear separation, gives us front-row seats to this reddish ghost's pulsing coma and bizarre anti-tail. Feel the shift, from despair to defiant hope. This blackout's cosmic tease has us all on edge, so comment below. Have you ever missed a once-in-a-lifetime sky event? Share your story. Subscribe for more. We're heading to Mars next, where the real show unfolds. The blackout's roots dig deep into celestial mechanics. Solar conjunctions have plagued missions before. Think Mars rovers losing contact. But timing one with an interstellar rarity? That's cosmic bad luck. Emotional vignettes bring it home. A young Indian astronomer, fresh from university, misses her first big observation, turning to virtual simulations to cope. An elderly Italian enthusiast, binoculars in hand, reminisces about Halley's Comet while lamenting this veiled visitor. These stories humanize the science, making it relatable across borders. Historically, comets like Halley in 1910 sparked panic. Hale-Bopp in 1997 fueled cults. But 3I/ATLAS. It's hope, binding us in shared wonder. Mars, that rusty rebel, scarred by eons of solar winds, emerges as humanity's unlikely hero. On October 3rd, 2025, as 3I/ATLAS swept within 29 million kilometers of the red planet, a cosmic high five, our fleet of rovers and orbiters lit up like Diwali fireworks. At 61 kilometers per second, this visitor blurred past, its trajectory hugging the ecliptic plane, a statistical rarity rarer than a four-leaf clover in the Sahara. From Jezero Crater's dusty rim to high orbits slicing the thin atmosphere, Mars morphed from exploration outpost to interstellar observatory, capturing data Earth could only dream of. Picture dawn on Mars, October 3rd. Phobos and Deimos cast fleeting shadows as 3I/ATLAS streaks across the sky like a reddish arrow. The emotional layers run deep. For engineers back home, it's vindication, after years of Perseverance's lonely trek. It's like our robot child sending home a postcard from another world, a JPL team lead shared in a funding lapse limited briefing. Globally relatable? Absolutely. From Bedouin nomads in Jordan mapping stars for navigation, to Inuit elders in Nunavut reading auroras as ancestors' messages, we all feel the pull of distant lights. This is our shared wonder, bridging cultures in a narrative of unity. Here's the Martian magic in action. An ExoMars trace gas orbiter capture, showing 3I/ATLAS's fuzzy coma shimmering against the star-streaked void. Chills, right? The tempo quickens, from Mars' wide-angle gaze to the intimate stare of surface bots. If Mars Comeback has you cheering, like and share to spread the excitement. What's next? A rover's eye view that might rewrite history. The rendezvous was no fluke. At 0.1937 astronomical units from Mars, 3I/ATLAS was close enough for TGO's CAS-SIS to snap its elliptical coma, thousands of kilometers wide, while NOMAD hunted for CO2 and water signatures. Mars Express stacked short exposures for faint signals. These aren't just photos, they're emotional bridges. A European engineer in Nordwijk high-fiving colleagues as data beams home, mirroring the joy of a Brazilian kid tracking the comet via app. It's Lewis and Clark in space, mapping uncharted skies. From that rover tease, Let's soar to the symphony above. An international armada turning Mars into a bustling spaceport for science. ESA's Mars Express and ExoMars Trace gas orbiter lead the charge, their high-res cameras and spectrometers dissecting 3 I/A TLAS's light, like master chefs savoring rare spices. Cassie's captured the coma's fuzzy halo, nomad sliced spectra into thousands of wavelengths, revealing CO2 at 129 kilograms per second and water at 6.6 kilograms per second. These instruments peeled back the visitor's chemical veil, spotting OCS and CN amid the mix. The spacecraft's flexibility shone, pivoting from Mars-focused duties to this interstellar surprise. The UAE's HOPE orbiter joins with its EMUS UV spectrometer, originally for Martian air, but now probing ultraviolet secrets, its global orbit granting wide field sweeps. China's Tianwen-1 adds mineralogical spectra, its high-res imaging, confirming the coma's growth to thousands of kilometers. NASA's MRO, with high RISE's proven comet chops, retargets despite funding hurdles, prioritizing health checks. This is diplomacy in the stars, nations pausing earthly squabbles to co-author a cosmic chapter, evoking the ISS's spirit, but on steroids. ESA's JUICE, in cruise mode, snags faint November glimpses, data trickling in by early 2026. Each dataset is a puzzle piece in a global mosaic. The tempo shifts, slow build wonder at the tech, then quickening to human stories. A young Emirati engineer tearing up at her first hit, a Chinese team toasting with baijiu under Beijing lights. Relatable? Like a worldwide potluck, every culture brings flavor to the feast. If this armada's harmony moves you, comment your favorite space mission and why. Shares keep the story orbiting. Challenges were real. Thermal constraints, operational safety, but triumphs abound. TGO's 5-second exposures nailed the coma's extent, while Omega on Mars Express found gaseous clues. It's a global effort, from Darmstadt to Dubai, proving science transcends borders. From orbital overtures, we descend to the dust, where NASA's Perseverance rover, that plucky six-wheeler in Jezero Crater, pulls off a feat for the ages. On October 2nd, 2025, during a routine 9-minute sky survey with Mastcam Z, it snagged something extraordinary. A faint streak slicing the Martian night, time-stamped and metadata-rich, defying satellite paths or planetary drifts. At 21:33 local solar time on October 4th, Navcam confirmed it, the first potential surface sighting of an interstellar object from another planet. Calibrations were rigorous. Flat fielding, dark subtraction, artifact hunts, cosmic rays and ghosts banished. Astrometric overlays using JPL ephemerides match the streak's velocity to perfection, residuals under arcseconds. Brightness, spot on for a diffuse coma at 29 million kilometers. No glitches, no interference, just pure, heart-stopping validation. Delayed by funding reviews, but the emotion? Electric. Perseverance, our 2021 emissary, now a bridge to the stars, like your childhood robot toy growing up to be a hero. Globally, it's poetry. A machine built by American hands, eyes from international partners, telling a tale that echoes Aboriginal Dreamtime tracks or Polynesian wayfinding. Deep layers of legacy, hope for future generations. See it here, a streaked view from Perseverance, capturing 3 I/A TLAS as a faint line in the Martian sky. Tempo surges, from quiet calibration to triumphant reveal. Likes if this rover moment inspires you. Comments on what Perseverance should say next. With Perseverance's proof in pocket, let's peel back 3 I/A TLAS's layers. This reddish enigma rewriting comet lore. Pre-blackout images from Gemini South on September 4th showed a coma sprawling up to 26,400 kilometers, reddish as Martian soil from tholins. No classic dust tail, but a broad anti-solar tail, like a cosmic boomerang. Shells and arcs ripple out, hinting at episodic ejections. Not the steady sigh of solar system comets, but bursts like a star's heartbeat. Size? Hubble's July 21st gaze pegs the nucleus at 0.32 to 5.6 kilometers, likely under 1 kilometer, a behemoth rivaling Borisov. Velocity defies norms, 61 kilometers per second at discovery, peaking at 68.3 kilometers per second at perihelion on October 29th at 1.36 astronomical units. Low inclination at 175 degrees retrograde, rare for interlopers. Water gushes like a fire hose, 6.6 kilograms per second, with CO2 at 129 kilograms per second, unusually high. Emotional? It's intimate. This object's breath carries water, life's building block from another system's cradle. Relatable tears for astrobiology dreamers worldwide. See it here. A Hubble close-up showing the teardrop coma and reddish hue. That rainbow coma? Clues to origins. Share if water from stars moves you. Dust ejection, 6 kilograms per second. Small particles, 60 kilograms per second large, remains steady. No fragmentation yet. The tempo peaks like a crescendo in a cosmic symphony. Late September 2025, a coronal mass ejection, a solar plasma tsunami, slammed 3 I/ATLAS head-on. Scientists braced for chaos, outgassing flares, tail twists, maybe even a nucleus cracking under the sun's fury. The stakes? High. Typical comets buckle under CMEs, their comas flaring with ionized gas, tails snapping like whips. But 3I/ATLAS. It stood defiant, its reddish coma intact, anti-tail unmoved, no dramatic ion tails or fragmentation. This resilience baffled plasma physicists, suggesting armored ices or buffered innards forged in an ancient metal-poor star system. The emotional core hits deep. Nature threw its mightiest tantrum, and 3I/ATLAS met it with grace, mirroring human grit. Think refugees weathering storms or activists facing backlash. Globally, it's pure inspiration. In Tokyo, plasma modelers burned midnight oil, their screens glowing with simulations that failed to predict this poise. In Nairobi, storytellers wove resilience myths, likening the comet to a warrior enduring a cosmic tempest. JWST's August 6th data hints at an insulating crust protecting volatiles, challenging every model we've got. One physicist tweeted, "This thing's built like a tank from another galaxy," sparking global memes. Egyptian students joking it's Anubis guarding the stars. Brazilian forums calling it a cosmic capoeira master dodging blows. This defiance isn't just science. It's a metaphor for endurance. Think of your own battles. That exam you aced against odds. That dream you chased through doubt. 3. I/ATLAS embodies that spirit. A reddish beacon saying, keep going. If this cosmic stand moves you, smash that like button and comment. What's your story of beating the odds? Share this to inspire others. Let's make this tale a global rallying cry. The data's still trickling in. SOHO's coronagraph caught the CME's path, predicting shock fronts, but post-impact spectra from Mars Express showed minimal change. CN lines steady. No new emissions. This suggests a surface that shrugs off solar particles, perhaps layered ices, or a crust baked by eons of cosmic rays. The implications? Huge. If 3I/ATLAS can withstand solar fury, what else might it reveal about its origins? Was it born in a turbulent disk, hardened by stellar winds? The questions burn, and the answers lie in data still locked in calibration queues. The debate over 3I/ATLAS rages like an academic storm, splitting scientists into camps as passionate as rival football fans. Is it a traditional comet or an anomaly defying all labels? Its hyperbolic trajectory, with an eccentricity of 6.14, the highest yet, seals its interstellar passport, outpacing Oumuamua's 1.2 and Borisov's 3.4. The pro-comet camp points to the coma, gas emissions, and activity. CO2 dominates at an 8% mixing ratio to water, unheard of at 3.32 AU plus CN Ni vapors, and a faint anti-solar tail stretching 100,000 kilometers by mid-September. It's active early, at 6.4 astronomical units, driven by volatiles beyond water. a classic sign of an icy birth in a distant disk. But skeptics fire back with a vengeance. The absence of carbon chains like C2 or NH2, no Fe alongside Ni, and an early reddish, featureless spectrum screamed asteroid to some. Initial reports lacked a clear coma, sparking asteroid or comet whispers on X. High negative polarization, a sun-facing plume, and stable structure. No outbursts, no fragments, challenge ejection models. Its age? 3 to 14 billion years, possibly from the Milky Way's thick disk, older than our Sun, with a metal-poor composition hinting at primordial formation. This isn't just nomenclature nitpicking. It's about the burden of proof for cosmic oddballs. Then comes the wild card, speculations from Harvard's Avi Loeb and others, suggesting artificial origins, a probe, citing the anomalous size, ecliptic alignment, and chemical quirks. An Archive preprint posited extraterrestrial tech due to the low inclination and missing molecules. Critics like Scott Manley and David Kipping slammed it as hype, with consensus holding firm on a natural comet post-JWST's detections of CO2, water, and CO.SETI's paper debunked alien claims, emphasizing natural explanations for Ni without Fe, perhaps radiation exposure or an insulating crust. The emotional pull? It's the thrill of uncertainty. Hearts race at what if, but science's rigor grounds us, echoing Oumuamua's lessons. Premature speculation fades under scrutiny. Globally, it's relatable chaos. Think ancient myths. Mayans saw comets as omens, Chinese as dragons. Today, a Filipino forum buzzes with theories. A Russian podcaster debates Loeb's ideas. From a Moroccan classroom sketching the coma to a Canadian retiree modeling orbits, this debate ignites curiosity. If this chaos sparks your wonder, comment your take. Comet, anomaly, or beyond. Like and share to fuel the global debate. Polarization studies reveal an icy dark mix, while an approximately 16-hour rotation adds spin, literally. With a V infinity of 58 kilometers per second, backtracking 4.27 million years finds no origin, pointing to galactic frontiers. This debate isn't just about labels. It's about how we greet cosmic messengers. The science is meticulous. VLT's September spectra showed CN asymmetry. JWST's NIRS PEC caught heavy 13C and CO2, clues to a unique formation. But the human side? It's raw. A grad student in India stays up late, arguing comet status on Discord. A Brazilian astronomer, grounded by funding cuts, finds solace in public data. This is science as a shared quest, messy and beautiful. Amid funding lapses delaying official releases, the story of 3I/ATLAS unfolds through data democracy, a cosmic treasure chest open to all. ESA's Planetary Science Archive and UAE's Mars Mission Data Center flood with FITS files and JPEGs, TGO's coma shots, Nomad's molecular hunts, Mars Express's stacked exposures. NASA's repositories, despite shutdowns, trickle prelapse gems, Hubble's July 21st teardrop coma, JWST's August 6th NIR spec revealing heavy 13C in CO2, CN asymmetry spanning 180,000 kilometers. Community mailing lists and databases like COBS light curves cross-reference in hours, syncing with JPL Horizons ephemerides. Independent analysts are the unsung heroes. Hours after raw drops, image stacks, photometric curves, and orbital fits emerge, vital during embargoes. Citizen scientists from Brazil to Bangladesh process data, spotting CN onset or tail growth. Emotional empowerment runs deep. A high schooler in Nigeria uses free tools to model dust rates. A retired teacher in Canada verifies anomalies. It's global. African forums share spectra. Asian groups debate composition. Relatable? Like open source code revolutionizing tech, this is the cosmos for all. Platforms like the SkyLive guides and Archive preprints, e.g. Frinka et al. On photometry, spark discussions, while VLT sequences and Gemini tail images foster collaborations resolving puzzles like high CO2's implications for alien disks. The challenges? Data queues and embargo delays, but staggered releases build anticipation. Picture a Mexican amateur astronomer telescope in her backyard, cross-referencing TGO images with JPL paths. Her kids cheering as she spots the anti-tail. Or a Chinese student up late, modeling coma expansion on a laptop. This is science as a global campfire. Everyone's invited to share the story. If this inclusivity excites you, comment how you'd analyze the data. Share to empower more. The tempo slows for reflection, then quickens as new datasets promise revelations, from sulfur-oxygen clues to tail evolution. This isn't just data, it's a movement. From a Kenyan app developer building a 3i/ATLAS tracker to a German retiree blogging light curves, the community's heartbeat drives discovery. Tools like Astropy and Stellarium make it accessible, while forums cross-check anomalies. The result? A collective unraveling of a cosmic mystery, proving science belongs to us all. As 3i/ATLAS rockets toward perihelion on October 29, 2025, at 1.36 astronomical units, the universe holds its breath. Will it brighten to magnitude 11.5, visible in backyard telescopes? Will outbursts flare as solar heat peaks? Post-perihelion, Earth's closest approach on December 19th, at 1.8 astronomical units offers renewed views. Hubble's November UV spectroscopy, probing gas ratios, sulfur-oxygen clues. ESA's JUICE, catching faint November glimpses, won't deliver data until early 2026, teasing tail evolution. The questions swirl like the coma itself. What's driving this reddish glow? Why the resilience, the missing molecules? Fundamental mysteries pulse at the core. The composition, depleted carbon chains, Ni without Fe, hints at a metal poor, ancient birth, perhaps 10 billion years old from the Milky Way's edge. The layered coma, absent dust tail, and CME defiance suggest a crust buffering volatiles, challenging every comet model. Staggered data, Webb's ongoing analysis, SphereX's August observations, promise revelations into 2026. Juno at Jupiter in March 2026, and Psyche's September pass could add pieces, while implications ripple. Rewriting protoplanetary chemistry, hinting at astrobiology with water gushing like a cosmic spring. This saga is a testament to distributed networks and cooperation, but also to limits. Geometry and politics create gaps, yet Mars' role proves redundancy's power. The emotional close? It's our shared curiosity, from Peruvian shamans reading stars to Silicon Valley coders crunching orbits. 3i/ATLAS is more than an object. It's a mirror, reflecting our hunger to know the unknown. Picture a child in rural India, eyes wide at a comet app, or an elder in Iceland weaving this into sagas. This is humanity's story, told in reddish light across the void. If 3i/ATLAS has stirred your soul, like, share, and comment. What does this cosmic visitor teach you? Subscribe for updates as this mystery unfolds. The horizon's endless. New spectra, new missions, new truths await.